Quadratic. So we are taking a quadratic from standard form ax squared plus bx plus c is equal to 0, and we're changing it to vertex form or graphing form. Same thing. So this is graphing form. A times x minus h squared plus k is equal to 0. So the whole reason we would want a quadratic from standard form to vertex form is simply for a couple of reasons. On the end of level test or on a test, they might say, write a quadratic in vertex form. Or they might say, write the quadratic, this is how I've seen it worded, write the quadratic in a different form. Well, if you have it in standard form, you can switch to vertex form. If you have it in vertex form, you can switch to standard form. So they're equal, they're just different forms. We have learned this. You do it by the method of completing the square. We've learned this, it was a long time ago though, so it's a good review. And then also, guys, solving the quadratic in vertex form is easy. Remember, we've done that as well, so we're going to practice that today too. Solving a quadratic in vertex form is easy. So it's kind of nice, because if you have it from standard form and you change it to vertex form, it's pretty easy to solve. So let's just do, oh yeah, these are the steps. Like you should already know them. We've done it before. If you need a picture of it, that's fine. But here's the steps to take it from standard form to vertex form by the method of completing the square. First, it has to be in standard form and set equal to 0. Most important thing. Then also our a value has to be positive 1. If it's not, we've got to factor that value out, divide it by each term, and then we can start. So then second, you have to find your square, which is always b divided by 2 squared. So this is the formula to find our square. That's why it's called completing the square. We're finding the value that makes it a perfect square. So we take our b value divided by 2 squared, and then third, you'll insert your fancy 0 after bx. So you'll go after bx, insert your fancy 0. You'll add your square, subtract your square, just so you don't change anything. That's why we call it a fancy 0. And then fourth, you'll group the first 3 terms and factor them, and you'll group the last 2 terms and add them together. And then you have it in vertex form. Sounds a lot longer than it really is. So these are just the steps. So let's practice this couple today. We've already learned this. Shouldn't be new to you. Okay, so let's go through this. Number 13, so it says, I'm starting on the back. Rewrite each equation in vertex form, and then I'm adding in then solve, because we need practice with solving. So we're going to go through and do this. So right now it's in standard form, ax squared plus bx plus c. So I am going to set it equal to 0. So I'm choosing to set it equal to 0. So we have x squared plus 4x plus 3 is equal to 0. Now you check, is it in standard form? Yes. Is my a value positive 1? Yes. So everybody, do you understand that your a value is 1, your b value is 4, and your c value is 3? Do you all understand that? Okay. So then I say, okay, I can start. So I'm going to find my square. It's always b divided by 2 squared. Now we always showed our work with this because remember, it helps you because there's a trick. You can use your work to factor much quicker. So my b value is 4. So I'm doing 4 divided by 2 squared. If you show your work, you're going to be able to use it. So 4 divided by 2 is 2 squared, which is 4. So our square is 4. We're inserting our square after bx. So we're inserting it in after bx. So we still have x squared here in front, plus 4x. Then we add our square. So we add 4. Well, if you add 4, you changed it. So to even it out, you've got to subtract 4, because then really you just added a fancy 0. So after bx, I put in plus my square minus my square. Does everybody understand where I put it? Then we still have plus 3. Then you group the first 3 terms and factor. Group the last 2 terms and add. Now here's what you have to, I'm going to caution you. This is always a negative, so don't forget that. Most common error is forgetting that that's negative. So we're going to factor this. Now the nice thing is, we don't really even have to know how to factor for this because we can use our trick. We can look back inside our parentheses. Before you squared it, it was positive 2, right? So it's going to factor, if we were to do this the long way, what multiplies to be a times c adds up to be b and go through this. It's going to factor to be, since that's positive 2, it's going to factor to be x plus 2 squared. It'll be x plus 2 times x plus 2, which is x plus 2 squared. And then we're going to add these 2 together. Negative 4 plus 3 is negative 1. And guess what? You have it from standard form to vertex form. Now from there, it was equal to 0 up here. It's still equal to 0. So I want us to practice solving. So now we'll just solve. So solving when in vertex form. You will isolate the x squared part. So I would add 1. So I have x plus, why did that just malfunction? Why does it do that at the worst times? So we isolate the x squared part. So we have x plus 2 squared is equal to 1. Now we'll undo the square by taking the square root of both sides of the equation. Our root cancels out with our power, leaving us with x plus 2 is equal to, if you forget the plus and minus, you're going to get it wrong. The square root of 1 is plus and minus 1. So then from there we can split it up. We're going to say x plus 2 is equal to positive 1. And we also have x plus 2 is equal to negative 1. And then just solve for x piece by piece. So up here I'm going to subtract 2. So I have x is equal to negative 2 plus 1 is negative 1. There's 1 in my solutions. Quadratics always have 2. We know that. The highest degree is the number of solutions it has. And then from here, we'll solve for x as well. Subtract 2, subtract 2. X is equal to negative 3. There's our 2 solutions to our quadratic. Questions? None? You're done? Sweet. Then you could start with us because we barely started if you want. All right, let's do another one. Number 21. So this is the last one I'll do, then I'll just let you do a few and then we'll call it good. So on number 21, we have 2x squared plus 4x minus 3. So the first thing you have to do is set it equal to 0. So 2x squared plus 4x minus 3 is equal to 0. Then you have to check if it's in standard form, and it is. Now you have to make sure your a value is 1, and it's not, it's 2. So we're going to factor out a 2. Now remember, the reason we do that is because if you factored out 2, technically what you did was you divided each term by 2, what you factored out. So we're going to write what's left in our parentheses. 2x squared divided by 2 is x squared. Positive 4x divided by 2 is plus 2x, right, people? And then minus 3 halves. Okay, we'll leave it as negative 3 halves. And then it's equal to, what's 0 divided by 2? It's still 0. Does everybody see how I did that? Now I'm going to ignore the 2 out here for a minute, but not forget it in my final answer, else I'm in huge trouble. So now I'm just going to do the same process we did before. You factor it, we're completing the square. So now our a value is 1. We can find our square. It's always b divided by 2 squared. Our b value is 2. 2 divided by 2 squared, which is 1 squared, which is 1. So we're inserting 1 into our function after bx. So we have x squared plus 2x. We add our square, so add 1, subtract 1, and then we still have minus 3 halves. Then you group the first 3 terms and factor. Group the last 2 terms and add. Now there's a trick. You can always look back in your parentheses before you squared it. It was positive 1. If it would have been negative 1, we would have x minus 1 squared. But since it's positive 1, this piece is going to factor to be x plus 1 squared. And if you add up negative 1 plus negative 3 halves, you get, correct, negative 5 halves. Then from there, you cannot forget that with this problem, we had factored out that 2. So that 2 is being multiplied to all that stuff. So our 2 is being multiplied to all this stuff. So now to keep it in vertex form, I'm just going to say, okay, we're multiplying it to this piece, and we're multiplying it to this piece. I'm going to keep the 2 out in front here, obviously, because we can't multiply it in, because then we'd be squaring 2. So we leave the 2 on the outside of the x plus 1 squared. And then if you needed to, you could take your calculator and type in negative 5 halves times 2. If you type it in, you're going to get negative 5. And then it's in vertex form. And now it's quite easy to solve. Solving in vertex form is one of the easiest ways to solve a quadratic. So questions on that before I set it equal to 0 and solve. So we would now isolate the x squared part completely. So we have 2 times x plus 1 squared is equal to 5. I'd add 5 to both sides. Divide both sides by 2. Do not take the square root right here. That's a common error. That 2 was multiplied in front. So divide by 2. So we have x plus 1 squared is equal to 5 halves. And now we'll take the square root of both sides of the equation. So our root cancels out with our power, leaving us with x plus 1 is equal to, if you ever have a fraction, you split it up, the square root of 5 over the square root of 2. Now, guys, we have to be able to kind of think advancedly for these problems because we have to say that we have to do what? Perfect. We need to rationalize our denominator. That's not, oh, and we can't forget plus and minus, but yes. So we would need a way to remember that. So we need to rationalize the denominator. Because there's a radical in the bottom, we have to fix it. So we multiply the bottom by the square root of 2 and the top by the square root of 2. So I have x plus 1 is equal to, on top I have, well, plus and minus, and then on top I have the square root of 10. Because they're both under the square root, you can multiply them together. And on bottom I have the square root of 4, which is 2. So now we have a 2. And then last step is to get x alone algebraically. So I'm going to I like to split it up. So I have x plus 1 is equal to the square root of 10 over 2. I have x plus 1 is equal to negative square roots of 10 over 2. And then from there, I would subtract 1 from both sides of the equation. We always write the whole number part first, so I'm going to write negative 1 plus the square root of 10 over 2. They'd actually even simplify that further. I'm okay if you stop there. And then we would subtract 1. I write the whole number. You need to write the whole number part first. So negative 1 minus square roots of 10 over 2. There's our two solutions. All right. So I won't make you do that many. You have 15 minutes to do some. Check your answers with me. I'm going to have you do... Okay, let's see. I'll have you do the front page, evens, all evens on the front page. That's it. So, back page evens. So, you're going to be doing, I'll write down the exact problems. You're going to be doing 14, 16, 18, 20, and 22. I think that's fair. Because I was going to have you do the whole worksheet. I cut it down to those problems. Ready, set, go.